provide you some insight about the today lecture. Okay, so very good afternoon, everyone. Today is the week 6 of this soil mechanics coursework. My name is Sumit Kumar. I am the PhD research scholar at IIT Islamabad. This coursework is taught by Dilip Kumar Beth sir from IIT Kharagpur, and this is the sixth class of this lecture series, and we are going to finish the entire coursework in the 12th session, which is going to be takes place every Saturday from 3 to 5. So these things are the basic things. In this course, we are studying the basic soil mechanics concepts, in which we have read the various aspects. Today, we are going to study the shear strength of soil. In addition to that, the vertical stress application like the Bosnick theory and other thing which we have read in the previous class, as I have said in the previous class. And that I'm going to solve some problems which would be asked in the engineering services or the GATE examinations. So the similar problem which we are going to cover over here today at the end of the session. In the meanwhile, for the shear strength of soil, whatever the presentations, whatever the things which is already with you, maybe with on the NPTEL website for the course description. In addition to that, I have made some slides to describe the shear strength in different way. Some of the tests which is not discussed yet in this coursework will also be going to discuss in this class. So I think this class will be interesting. Talking about the problem aspects, today in today's class at the end we are going to solve the problem related to vertical stress, like the question related to Bosnick theory, which are normally asked in GATE examination. I have taken the question from there only, and in addition to that, we are also going to study understand the shear strength, shear stress of soil, and the various tests which could be used to calculate those values. Moving forward, in the next class, we are going to solve the problem associated with that. In this class, we cover only theory up to that aspects, and from the next class, the numerical problem associated with the same will be discussed with you. Okay, so now we can start with the content. In addition to that, I want to add some point like these PDF or PPT presentation, whatever I showing over here will be shared with you through the Google Drive link, and this session is recorded by me. We will also be uploaded on the YouTube channels. So from there you can see this content later as well if you are not able to attend the session live, and if any other issue will be there regarding the network or maybe audio video problem in the whole lecture series, you can tell me at any point of time. Some point of discussion you want to add on, that is also welcome, but if some doubt would be there, I am happy to answer. But I feel the content will be sufficient to answer your problem. But if any problem arise, if at any point of time due to network issue, audio and PPT are not visible, you can tell me at any point of time. Okay, so let's start. And in the soil mechanics today, what I said that we are going to study the shear strength of soil. So first of all, starting with in the previous class, the vertical stress applications problems we are dealing with. Okay, so one problem is mentioned over here, and this question say that the uniform contact pressure under a rectangular footing of 6 meter by 5 meter is 200 kPa. Compute the vertical stress component at point A and B at a depth 2 meter. Okay, so you can see over here the dimension is mentioned as 6 meter into 5 meter, and we have to calculate the stress at point A. Okay, so in the previous class, we understood the concept to calculate the stress at any point if stress is applied at any other cross section, like from the Bosniak equation 3 by 2 pi into 1 by 1 plus r square plus z r square by z square whole power 5 by 2. So that concept we have read, conforming that concept to this problem. How we could able to solve, we will see, but the theoretical aspects of this is not discussed. So this question solution also I haven't mentioned in the PPT, so it is very difficult for me to solve with pen and paper in slides. So let me provide the solution for this in the PPT once I shared with you, and any doubt remain there, I will discuss it in the next class if the doubt remains, because with this PPT, I pen and paper, this is very difficult for me to solve at this point of. Okay. So, or maybe at the end of class, if I have time, I solve on the pen and paper and take the image of that and show you over there. So let's see what we could do with this. But the main concept, shear strength, which I am keen to discuss in this class. So let's start with shear strength. At the end of class, we will see about it. Okay. So, starting with the shear strength, what is the shear strength? What do we mean by shear strength? First of all, we read the this PPT, which content is discussed in the class. Additionally, I have made some other PPT as well to elaborate the concept of the shear strength. So, in the first 30 minutes, we will quickly discuss the shear strength, whichever the presentations files are there or whatever discussed in the class. From the last week, but in additionally I have made some other presentation also, so that could be more helpful for you if when we discuss those things over here. Okay, so starting with the shear strength. So in many soil mechanics problems, the shear strength of soil emerges as the one of the most important characteristics, and the problem group may include the stability of slopes, and how it is associated with that we will also see. The stability of slopes, cuts, embankment, dam, hill, ultimate bearing capacity, lateral pressure against retaining wall, seating or bracing, or the friction developed by bypass. Everywhere is the shear strength. Okay, let me ask you a question. Like you have said, specifically in the strength of material, or maybe RCC, or maybe the steel structures, the strength has different meaning, because over there the material parameter is there. If you are using the mild steel, it might have some tensile strength, it might have some compressive strength, right? But in term of soil, when we talk about the strength of soil, we talk about shear strength of soil, how much strength it has, and the shear strength developed due to the two of the most important shear strength parameter, that is, sorry, okay, and the shear strength developed due to two of the most important shear strength parameter, that is cohesion and angle of internal friction. How the cohesion and angle of internal friction provide the strength of the soil is also very much important. So, as name, from name, cohesion, cohesive characteristics, and angle of friction particle to particle. Okay, we will see. Specifically, we will discuss that what property give strength in what type of circumstances, or maybe you know that the maybe not you have known. Basically, in the first class only we have classified the soils on the basis of strength. We also said that the fine grained soil, coarse grained soil, we have studied the cohesive and cohesionless soil. So those aspects property are there. When we say that the cohesive soil, the prime strength parameter contributed over there, prime shear strength parameter contributed over there is the cohesion. Subsequently, for the cohesionless soil, it may be fixed. So, those things become very much prominent when we are discussing those things, right? So in the every aspect, the strength is very much important, because at any field, at any place, maybe irrespective of the field of engineering, maybe the civil, mechanical, or any field of engineering, over there, if you are using any material, the strength become prominent, what much strength it have in resisting the specific amount of load or the specific characteristics. So the shear strength become very much important. Now, in term of soil, when we say strength, normally we say shear strength. When we go into the foundation, we talk about the ultimate bearing capacity. We also come across the calculation of the bearing capacity based on the strength criteria, shear strength criteria, or maybe settlement criteria. We'll see once we move over there. I don't think if you have a little bit idea about that, you could understood that what I want to say in terms of the shear strength criteria and the settlement criteria, both based on the shear strength characteristics and how much settlement a foundation could be. So that is not the point of discussion at this point of time. Let's move ahead and see what we are going to discuss at this point of time. Okay, so the shear strength of soil may be attributed by the basic component like the frictional resistance to the sliding between the soil particle, cohesion and adhesion between the soil particle, interlocking and bridging of the soil particle to resist deformation. It is, as said earlier, that the cohesion and adhesion between the soil particle or maybe the interlocking between the solid particles will result in the strength to the soil, which ultimately reflects the shear strength. It is neither easy nor practical to clearly delineate the effect of these components on the shear strength characteristics, shear strength of the soil. So these properties become very much prominent in compelling the shear strength characteristics of soil. Additionally, the component shown before, like the cohesion angle of internal friction, may be influenced by some other factors. What are those factors? Those factors are the moisture content, obviously. You know, we have read about the stress, various type of stress, like the vertical stress, total stress, effective stress, the stress developed due to poor water. So those types of stress get developed. Over there, you have understood that if the water table get present, the pore water pressure get increased and the effective stress get reduced, which become the prominent concepts in the field of geotechnical engineering. Hence, the pore pressure, change in the moisture content, structural disturbance, fluctuations in the groundwater table, underground water movement, stress history, time, perhaps chemical actions or the environmental conditions also play a very important role. So you need to understand that the shear strength characteristics is influenced by the cohesion and angle of internal friction, but those components may those soil characteristics, in addition to that in addition to that, like the unit weight of soil, degree of saturation, void ratio, everything could be affected by these components. Hence, this become also very much important when talking about the shear strength characteristics of soil. However, you can see that there are number of tests, both laboratory and the field, that are used to obtain measure of shear strength of a given soil. A combination of the theoretical with the experimental effort provide the background and tools for the basic understanding of the phenomenon related to the shear strength of soil. Over here, you have seen that we have talked about the various tests which are over there to understand the shear strength characteristics. So let me complete this presentation. Then additional presentation is also there for you. Over there, we are going to discuss the shear strength characteristics of soil and how it is calculated with the different type of test, like the box test or the direct shear test or the triaxial test, or maybe uh, uh, and maybe box test. So those type of tests which we are going to discuss in the triaxial test, like the UU test, CO test, CD test, those things also we are going to discuss briefly in this class. Subsequently, if in this curriculum, and the advanced descriptions of the test would be needed, and that is also followed in the next class. And the test concepts is become very much important, because if you know the basic equation which you use to calculate the shear strength is equal to S equal to C plus sigma and tan phi. Let me write. Shear strength is equal to cohesion plus sigma n, or sigma effective, sigma n dash tan phi. So this is the basic term we use to calculate the shear strength. Where C is the cohesion, phi is the angle of internal friction, S is the shear strength, sigma is the effective stress, or the total, the effective and total both term we can calculate. Sometime for the effective we say that S equal to C dash plus sigma n dash tan phi dash, and over there we say that C and phi are the effective shear strength parameter, while if we use the C and phi, you say total strength shear strength parameter. So we will discuss that as we move ahead, but this is the basic equations we use to calculate the shear strength of soil. So from this equation you see the cohesion and angle of internal friction is important. In addition to that, the stress, effective stress which is developed is also one of the important aspects. As we move ahead, we see with the help of some of the figures that how the shear strength get affected when once the uh, and how the failure takes place due to increase of stress above the shear strength of soil, that we are going to see. So I move quickly with this because these things is already discussed in the class. If you have moved ahead with the lecture of the sir, then additional point or the additional presentation slides which I have created for this class, we will discuss that. Okay, so let me move ahead slide by slide, and let's see that how we are going to discuss those. Right. So with the sum of the appropriate modification, many of the concepts used in the some of the basic mechanics courses can be employed to explain the various phenomena in soil. Okay, so I'm not going to discuss this over here with these slides. Let me move ahead. I am directly going to the my slides, because these things already discussed with you. These points, like various other factors influences the shear strength of soil, like degree of saturation, particle size, shape. Okay, we will come to this slide later. First of all, let me discuss with my slide, and then we will come over here. Okay, let's see. Let's first of all understand about the shear strength of soil. Then we will go ahead in the descriptions of other thing, like how the problem associated with the Mohr circle, and many more problem could be elaborated and solved. So let's start with the very basic concepts again with definition over here. So the basic definitions say that the shear strength of soil is the ability of soil mass to resist the shear forces. It is the measure of soil resistance to deformation or failure when subjected to the shear stress. Shear strength is an important property in geotechnical engineering, as it determines the stability and the load bearing capacity of soil structures such as foundations, retaining wall, and slopes. This is also mentioned in the earlier slides which we were discussing at the earlier point of time. Now, the shear strength of soil is typically represented by the two parameters, as I have said. The shear strength parameter, that is the cohesion and angle of internal friction. Now, how the cohesion and angle of internal friction contribute to the shear strength of soil? become prominent. Over here, we could say that the cohesion represents the shear strength of soil particles due to the intermolecular force and is more significant in the cohesive soil such as clay, because in clay this intermolecular force get developed widely because of the cohesive characteristics of the soil particles. While the angle of internal friction represents the resistance of soil particle to the sliding and is more relevant in the cohesionless soil such as sand. And this is very much understandable, because suppose when you see the sand, all of you must have seen, I will take the simple example, not the sand is used in the construction practices, that sand only. If you see the over there is no intermolecular force of attraction. If you take the sand in the hand, it will flow between the fingers very easily. So you can observe over there that the resistance, if we consider that as a soil particle over there also, because that sand is nothing but a soil only that is found near the river or bed, or maybe near the oceans. So sand is also soil only. So over there the but that also provides strength. If sand doesn't have strength, suppose you are standing on any soil, at any place, if you have stand over there, it has that much strength, so it can sustain your weight. If it doesn't have strength, it become marshy, then you are going to drawn down into that sections. If you are standing over there without any disturbance, so it must have that much strength to bear your weight. Suppose a sand is placed at some place, suppose at the near the river banks or maybe sea banks, the sand is there. Over there you stand, does you feel uncomfortable that you are going inside the ground? That's not the case. No, hence it's have a strength to sustain your load. Additionally, if you see some of the very good constructions works also takes place in the vicinity of the sea beaches. If those construction works are there, so that the load must be there, which is sustained over there. Hence it become very prominent that the angle of internal frictions, is the resistance provided by it by the particle to particle sliding movement, and it is widely relevant in the case of sand, right? Now, the shear strength of soil can be determined through the laboratory test, right? And the field test as well. The type of laboratory test like the triaxial shear test, direct shear test, which is also known as the box test. And these are the most prominent tests which we use. In addition to that, some other tests are also there, like okay, some other tests are also there, like um, um, which we could use to calculate the shear strength of soil. These tests help engineers in designing the safe and stable structure by considering the shear strength properties of soil. Now, see the importance. The why this is very much important, because shear strength plays a crucial role in development of the understanding of the strength characteristics of soil. So the safety of any geotechnical structure is dependent on the strength of soil. Obviously, if the soil fails, a structure founded on it can collapse, engaging in the life and causing economic damage. It must be obvious. And the for that reason, okay, let me read first of all. For that reason only, if you see, if any of the if you meet any of the practicing engineers, the first thing they ask before any construction practices is the soil report. If any design engineer, any practicing engineer are there, if you meet them, say that I want to construct some apartments or maybe some hotels, uh, they say that first of all give me the soil report of that site. Over there the construction is going to take place, not only for the construction of multi-story buildings, but for the construction of roadways, railways, or maybe bridges. At every instances, first thing asked by the practicing engineer is to provide the soil report. Why that soil report very much important? Because from that only the characteristics of soil present at the specific site could be known, and that characteristics could be used in order to evaluate the strength of the soil at those sites. If the constructions require more strength than the desired, than the present strength at those sites, then some improvement techniques could be employed in order to achieve the required strength. Because if the strength at those sections would not be to bear that much load which get applied by the construction practices, then the building get building or maybe the roadways get damaged in the due course of time, and that will lead to the large loss to the lives as well as economy at some point of time. Hence, we can say that the strength of soil is therefore the very much important for the geotechnical engineers. And the word strength is used loosely to mean the shear strength. In term of soil, when we say that what is the strength of soil at this XYZ site, so over there we mean to say the shear strength, which is the caused due to internal friction and the internal friction resistance of the soil to the shearing forces. The shear strength is required to make the estimate of the load bearing capacity of soil and the stability of the geotechnical structure. And in analyzing the stress strain characteristics of soil. Now, moving ahead, talking about some more point regarding the shear strength. So, give me a minute. Okay. So, I am talking about some more point like the shear strength is a critical factor in the geotechnical engineering as it determines the stability and the behavior of soil under the different loading conditions. The understanding shear strength is essential for designing foundations, slopes, retaining walls, and other structures. Very much important. Shear strength play a crucial role in preventing the failures such as landslides, embankment, collapse, and the foundation settlement. Because the if these characteristics is known to the specific site, then we could model in the present time as the technology progresses, we could able to model, make the numerical model, we can able to do the finite element investigation related to same in order to evaluate the chances of danger. If we know, suppose at any specific site, if you have the knowledge that at that site this much strength of the soil, by doing various field investigations, when we have the soil report, we could evaluate in the various adverse condition possible. Talking about the embankment collapse or maybe landslides, over there we could also consider, we could do the analysis considering the rise of water table. At that condition, what would be the strength and how much safe those structures which we are going to construct. Additionally, the embankment collapse during the sudden drawdown or maybe due to the heavy rainfall, what is the effect maybe resulting in the landslides, how much the factor of safety would be there, could be elaborated. These days you see that the various retaining structures, retaining walls are constructed to sustain the water or maybe the soil in the high-rise bridges. So those property, if we known to us, it become very much important. Technically, everyone, the one basic question regarding the soil, that if the soil characteristic is not up to mark, what is the primary solution? So first solution is to replace the soil, but practically whether it is possible to replace the whole soil from one side to other side in order to improve its strength? No, practically it is not possible. Hence, uh, we provide the other improvement technique to improve the shear strength characteristics at the desired site in order to achieve the desired strength. Right. Now, talking about the shear strength in granular soil. Okay, we one by one we will understood that the in shear strength in the granular soil as well as the cohesive soil, how it develop, how it's act. Okay, so let me see. Okay, let's move ahead. You see, give me a minute, please. Okay, talking about the shear strength in granular soil. So the granular soils like the sand exhibit the unique behavior under stress. The flexible boundary containers, the granular soil tend to flow when subjected to stress. While in the rigid boundary container, the volumetric deformations occurs leading to the change in the shape and the density of soil. Crushing, bending, and rolling mechanism can also affect the shear strength characteristics of the granular soil. So those things become very much important talking about the soil characteristics based on the granular characteristics of the specifically the friction characteristics. Additionally, talking about the cohesive soils, those cohesive soils such as the clay require the special considerations in terms of the shear strength. The compaction characteristics are crucial in achieving the desired shear strength in the cohesive soils. Decreasing permeability and preventing consolidation settlement are the key objective in compacting cohesive soils. The development of the shear stress and the slippage is a common in the cohesive soils under the excessive loading conditions. Okay, now talking about the what do we mean by the excessive loading condition? So the excessive loading can lead to the shear failure. What do we mean by the excessive loading? We will see with one of the images, one of the figure which is drawn over here to explain this. So let's see. Okay, so over here you can see that a failure takes place between these two bodies. And the parent body is shown to you and the detached body is shown to you. So suppose the critical strength above which if the strength of soil at that place maybe assume 100 kPa, and if the stress applied below that is maybe 98, 99, 99.5, 99.9, it is in the stable condition. But once the critical stress and the applied stress become equal, the strength and the applied stress become equal, it comes into the verge of failure. After increasing the stress from that point, it, little bit, it will result in the failure. So that point which we are discussing over here, that the excessive loading can lead to shear failure of soil, which can have the severe consequences. Talking about these things initially, a settlement may occur due to the applied load, but beyond a certain point, the shear failure can take place. The shear failure can result in the landslides, rock falls, embankment failure, and the other catastrophic events. Understanding the factors contributing to the shear failure is very much crucial in designing the shape stable structures. Hence, this excessive loading could be right? And how we know the shear strength characteristic? If we have performed the geotechnical investigation. Hence, the primary thing before any construction practices at any specific site, whether it is for the high-rise building or maybe for the road network or the rail networks, it become very much important, or maybe the retaining structures or maybe embankment slope. Everywhere, the first point of importance to mm, find the soil report which is obtained from the soil investigations. Talking more about the shear strength, it is become important to mention that the shear strength of soil is a fundamental concept in the geotechnical engineering, and understanding the behavior of the granular and the cohesive soil under the stress is essential for designing the safe and stable structures. When the excessive loading can lead to the settlement and the shear failure, which can have severe consequences. The triaxial elements analysis helps in studying the shear failures and identifying the critical failure play. The shear strength is the key factor in designing foundations, slopes, retaining walls, and other geotechnical structures. Moving ahead, we can say talk about the state of stresses. So the two state of stresses are over there. That is, first is the normal stress and second is the shear stress. How these develop, how we will solve it with the help of Mohr circle, and afterward the problem associated with the same we are going to discuss. But before that, let me see the problem which we have need to discuss uh, over here associated with the concept which we have discussed. Let me see that problem is there in the earlier PPT or not. Let me see. Give me a minute, please. Okay. The problem is here. We will come over here once we understood the concept. Okay. No problem. That question is not over here yet. So we will discuss once we understood the concept in better understanding. Okay. So let's move with the concept associated with the normal stress and the shear stress. Now, if you remember, at one point of time, I have mentioned something like S equal to C plus sigma tan phi, or you can say tau equal to C plus sigma and tan phi. So over there, the sigma n is the normal stress and phi the angle of interpolation. If you remember, I have written with the pen and that S equal to C plus sigma and tan phi. Over there, sigma n is the normal stress and S is the shear strength. These stresses are the result of the external forces acting on the soil mass. The criticality of the soil mass lead to the formation of plane where the stress are concentrated. Each point within the soil mass experiences the critical stresses simultaneously. Now, I already discussed this figure in which I have said that suppose the specific at a specific section, strength is 100 kPa. If strength is 100 kPa, it becomes very much important to note that the failure doesn't take place till the applied load of 99.9 or maybe 100 till 100. Sorry. till the 100 kPa of applied stresses, the failure is not going to take place. But once the stress goes beyond the value of 100 kPa, the failure takes place. Over here, the example of parent body and the detached body is shown over here. So the parent body means that whole soil sections is present at one point of time, like this. Like this, over here, this is the in the direction of the screen of the laptop or maybe mobile, wherever you are seeing this lecture. When you go in that direction, that is the direction in which the soil is moved ahead. But at the time of failure, these cross sections get detached from the whole soil section. So this is the detached body, while the whole cross section may be mentioned as the parent body. When the applied stress become greater than the critical stress at that point of time, at the point it is result in the failure. Okay. Okay, over here you can see the practical example. Take this figure and imagine over here. But over here, the entire road cross section is there at some point of time. At some point of time, from this section to this section, the road is constructed, but the failure takes place from over here. Now, one question could be arise in anyone's mind, that why the failure takes place at this cross section only. It could be possible that the failure takes place before these sections or maybe after that sections. But if the failure takes place from these sections here, hence one point could be said, could be concluded, that the strength at this specific cross sections is minimum, and it is the critical value, it surpasses the critical stress value resulted in the failure at this point of at this place at a specific point of time. Okay, so in this detached body, the soil move ahead from this is said to be detached body, while the whole road cross section could sit over here as a parent body. That what I want to mention with this help of example, with the help of this example. Right now, again you can see over there, the whole road cross section is there, and the failure takes place at a specific point of time due to the landslides in a slopy region. And this detached body, the failure takes place from those cross sections, so the strength at that section is minimal, hence resulted in the failure at that section. So the detached body is the body which is removed from the parent cross sections due to the failure of failure takes place over there due to the increase in the shear stress than the critical stress value. Right now, before moving to the triaxial test, let us take a 5-minute break, and then we move ahead. Because I am feeling some cough, so let me take a 5-minute break only. You also take a 5-minute break, and then we will come back. In the meantime, if you want, I give you some problem you could solve in this due course of time. Let me give me a technique. This is the problem from the discussion from the last class. So okay, this is the simple problem from the previous year GATE exam. GATE exams. So try to solve this. Okay. So over here, 5 minute break will be there. After 5 minutes, I will again start. Please be remain in the meeting. Okay, I hope you already have solved that problem which are present on that screen. So let me start with the discussion only. Once we end up the session, we will solve the all the problem, specifically whichever I have taken those problems asked in the previous year get examination. So at the end of session, we are going to solve that. And I also said, told you in the previous class that some other problem associated with the concept which we already read will be going to discuss, because the theoretical concept I feel uh, is already discussed with you in the lecture series of the NPTEL coursework. So the numerical problems are more important. And in this class also, whatever I am discussing about the shear strength is because that must become very much important. And my current PPTs and the presentations files could be more helpful in developing the better understanding of the subject. So we are over here there at the um, what are the different tests. So diaxial test or triaxial test. So we move from there only, and at the end we move to the second presentations file, in which some points are there. We, as per my understanding, once we discuss these things, the problem associated with the same would be very easy to solve out. Right. Okay. So we are here about the triaxial state of stress. Basically, how what type of stress could be applied at specific cross sections, and how we could understand if you suppose. Okay, let me ask first. Am I audible and the screen is visible? Anyone could write in the text or maybe respond. Am I audible and my screen is visible now? Please, anyone can
Yes,
respond.
sir.
Okay, okay, thank you, thank you. Okay, so what I want to say that what are the state of stress get developed, and we normally move forward with considering the two stress direction only, sigma x and sigma z. But in real, whether it happens and whether if it happens, what type of stress characteristics get developed in the soil? Suppose at wherever you are sitting, suppose a ground surface. In the ground surface, when we move below the ground surface and suppose some cross section of the soil, over there some stress is applied, and that the stress applied at that cross sections, let me take some box, or maybe suppose this is suppose this is the cross section of soil below the ground surface. This is actually not square, so let me show you this. Let me move to the my screen so that I could also see that what. Suppose this is the cross sections of soil. I am talking about this, and the ground surface is above, and we are taking this cross section below the ground surface. The stress applied on this from x direction, uh, basically from, suppose this is the x direction, and the vertical direction is the z direction, and the direction in the direction of screen is the y direction. So the stress applied in um, horizontal direction, horizontal x direction, and the vertical horizontal x direction, and the direction of the screen, that is the z direction, is identical. um, let uh, uh, let me give with another example. Suppose you can see this copy. So suppose, okay, this is a notebook, and suppose this is a soil cross section. If you take the soil at this point, if you suppose the soil at this point, the stress applied from the upward direction would be different, but the stress applied in the horizontal direction from this side to this side or from this side is same. Hence the if we say the horizontal direction as x direction, this direction as z direction, and the vertical direction as y direction. So we say sigma y is different from sigma x and sigma z, but sigma x and sigma z value at this point is same. So in the three-dimensional space, the stress act in this format only, right? Now, what I have explained this. Now let me read. You would understand very easy. That what I want to say, that the ground surface exerts the stress on the soil sample in the three direction, creating the triaxial state of stress. When we talk about the geotechnical material like soil are assumed to be isotropic homogeneous, although uh, these assumptions may not hold true. Obviously, if you understood, we say that the soil is homogeneous isotropic, but this is only the assumption. This is not practically true, but these assumptions hold good in the maximum cases. The stress characteristics or the strength characteristics we often assuming this is more or less accurate in the application process. Okay. Okay. To simplify the analysis, we transform this three-dimensional space to the 2D space, in which we focus only on the plane strain problem. Basically, if we can assume the two-dimensional space, we take the plane strain problem. In the plane strain problem, the effect of stress perpendicular to the plane is ignored, and over here you could see that in the two-dimensional space in the civil engineering, we can take the sigma x value as a sigma z. Basically, the stress in the two of the horizontal direction below the ground surface is assumed to be same, and the vertical stress which is acting over there, which also moving forward when we move to the triaxial stress over there, you see sigma 1 minus sigma 3 is the stress applied in the vertical direction. All right. So, okay. Once that point came, I will elaborate. So, the most engineering structure are the two-dimensional in nature, although they may appear three-dimensional. The two-dimensional cases are more prevalent in engineering practices. The three-dimensional problem can be simplified by choosing the slice of soil mass. Hence, the sigma x, sigma z, and sigma xz uh, are enough to explain the stress component in the two-dimensional cases. The angle acting between the normal and the shear stress component is represented by alpha. Over here, the sigma and tau are the function of the terms like the sigma x, sigma z, tau xz. In the coming slide, we see the interrelations which is obtained from sigma x and sigma z and sigma xz in terms of sigma and tau. But additionally, you would understand how these terms could help in the development of the Mohr circle, which is quite useful in elaborative term to describe the stress condition at a specific point in the soil mass. And this is very much, if you have understood the term related to sigma principal stress, principal strain in the concept of the soil mechanics, you would understand over here very easily if you have come across that subjects in your UG courses. So this understanding would develop very easily. So let me move slide by slide, just explain the things which are coming ahead associated with the forces to stress, conversion of forces to stress. So the in geomechanics, geotechnical engineering, the forces are converted into the stress, and the stress provide a more convenient way to analyze the behavior of soil. The external forces are converted into stress as sigma and tau and are represented on a plane. So the tau is mentioned as sigma x minus sigma z upon 2 into sine 2 alpha, while sigma is the sigma x plus sigma z by 2 plus sigma x minus sigma z by 2 into sine 2 alpha. Over here, you can see the Mohr circle is also plotted for the same, and the equilibrium equations are used to analyze the state of stress in the soil. The equilibrium equations involve the relationship between the normal stress sigma and the shear stress tau, and these equations can represented graphically using the Mohr circle. As you see over here, the Mohr circle are generated to form the equilibrium equations. Over here, the sigma 1, sigma 3 are the stress acting, the principal stresses acting is shown on the x-axis, while the radius of this Mohr circle, whether it has the center at origin or irrespective of center at origin, is said to be in the shear stress developed along at that point. Now, talking more about the Mohr circle, the presentations include the Mohr circle as a graphical tool used to analyze the state of stress. The Mohr circle helps in determining the stress component sigma and tau at a given plane, including inclined at angle alpha. The steps to solve the problem using the Mohr circle are explained along with the analytical method. You could explain that. Now see that the Mohr circle analysis is a powerful tool for understanding the state of stress in the material, the applicable to the various materials including soil, rock, and composites. The Mohr circle analysis combined with the material properties such as the shear strength allow for the analysis of the real life situations in the civil engineer. Now you can see over here the sign convention is shown, in which you could see that the horizontal in the horizontal plane, the anti-clockwise direction is assumed to be positive for the normal stress, for the shear stress, while in the vertical plane clockwise direction, basically positive shear stress direction and the negative shear stress direction is also mentioned. And the in the normal direction, if the compressive is applied, it is said to be compressive, and if it is applied away from the plane, it is said to be tensile, and the positive and negative direction respectively for the same. Now, talking about the shear failure is a common mode of failure in the soil, obviously, and in the simplified solution, the focus is on the shear failure and the rigid body behavior. The Mohr circle is used to analyze the state of stress in soil undergoing shear failure. The assumptions could be taken as sigma x is equal to sigma 1 as the major principal stress and sigma z equal to sigma 3 as the minor principal stress. Now, you need to understand that the state of stress in the soil is very crucial for the geotechnical engineer, as it is one of the important parameters to develop the understanding about the soil characteristics. The Mohr circle provides a useful tool for analyzing the stress and the failure in the soils. The soil samples um, is taken and a simplified solution, and the generalizations help in the practical application. Mohr circle defines the state of stress acting at a given point, which is sitting on a plane along which the failure is about to happen. Right. Now, talking more about this Mohr circle analysis, so the deriving the relationship between the sigma square and the tau square as a circle equation. So let's understand something. If you have remember earlier, there is a picture is there. There is a picture is there in which a circle is drawn like this. The vertical axis is like that, horizontal axis is like that, and over here the sigma 1 and over here the sigma 3 is mentioned, if you remember. I'm not going to draw sigma. So this principal stress sigma 1 is the principal major stress and the sigma 3 is the principal minor stress. The Mohr circle defines the state of stress at the point on the plane where the failure is about to occur. Talking about its practical application of the Mohr circle, it will help analyzing the equilibrium in the various material. Now, over here, let me explain each term one by one related to Mohr circle. So the first point over here you can see is the origin. So origin become very much important. So origin is nothing but sigma 1 plus sigma 3 by 2, and on the x-axis and on the y-axis it is always 0. Now, if you remember, the radius of the Mohr circle is the maximum shear stress. If you could see that the sigma 1 minus sigma 3 by 2, because let me take a laser point so to show you more clearly. Over here you can see that this is sigma 1 and this is sigma 3. If you subtract sigma 1 minus sigma 3, this diameter is obtained, and if we divide it by 2, the radius is obtained, and the radius of Mohr circle is the maximum shear stress, or the shear stress developed is the maximum shear stress. So in this manner you could easily obtain the maximum shear stress or the radius of Mohr circle. Now, talking about the sigma 1 as the principal major stress, while sigma 3 is the minor principal stress, and the horizontal axis is said to be the zero stress, zero shear plane, and the relation developed by using the radius and sigma and tau value is given as sigma square plus tau square is equal to a square. A or alpha is the radius of Mohr circle. Now you can see some other relation by which we could calculate the principal shear stress and stresses like the sigma 1 and sigma 3. Now if you remember earlier, we have mentioned that the sigma x, sigma z and tau xz remain there when we converted it from three-dimensional plane to the two-dimensional plane for the better understanding of the subjects. Hence, the relations which is used to calculate the maximum and minimum principal stress is given as sigma p1 is equal to sigma x plus sigma z by 2 plus sigma x minus sigma z by 2 whole square plus tau xz whole square. Subsequently, the sigma p3 value is also obtained as mentioned over here, and the value, the angle between two is given as tan 2 theta is equal to 2 tau xz by sigma x minus sigma z. Over here, the sigma p1, sigma p3 is the principal stresses, while the sigma p1 plus sigma p3 is equal to sigma x plus sigma z. If you remember the Mohr circle, the value of sigma x and sigma z remain constant, so the value of sigma p1 plus sigma p3. Hence, now let's move to the problem associated with these equations only. That is sigma p1 is equal to sigma x plus sigma z by 2 plus root under sigma x minus sigma z by 2 square plus tau xz square. So on the basis of this, the problem is measured over here. So this is the very simple problem. The problem says asked that find the origin and radius of the Mohr circle for the given state of stress. Additionally, one more point need to be found is to calculate the principal stresses and draw the Mohr circle. So first of all, you see in this plane which is shown in the colored red colored section, only the compressive stress in the vertical direction is applied. So the sigma z value is going to be minus 30 because the compressive, and in the sigma x direction there is no stress is acting, so in the shear direction. Hence, using the equation as sigma x minus sigma z by 2 square plus tau xz square to calculate the radius of Mohr circle, which is also going to be the maximum shear stress, the equation has been used as 0 minus minus 30 upon 2 chi square plus tau xz is 0, has 0 square. So this value is going to be 15 Hence, the sigma P1 value is going to be a sigma x plus sigma z by 2 plus tau. So sigma x and sigma z is known, that is the sigma z is going to be minus 30. Hence the value of sigma P1 is 0. Sorry. Hence for the sigma P3 value, this value get changed to be minus 30 as shown over here. When we are going to draw the Mohr circle, the radius is found to be 15, and so the diameter. Right. Okay. No problem. So I think so up to this there will be no problem. Now again the repetition of problem is there. So over here there is only change is provided. Now what is that change? That earlier the stress acting in the compressive direction, over here the stress is acting in the tensile direction. Hence this Mohr circle earlier at the left get shifted to the right as shown in figure over here. Rest of the thing like the radius and the point on the origin remains same. The only value get changed is the positions of Mohr circle, as the value of sigma P3 earlier came to be minus 30, over here the sigma P3 is 0, while the sigma P1 value is calculated as plus 30. Now you can see that again another problem is given over here, in which the stress acting in the x direction is assumed to be compressive as minus 60, while the uh, while the tensile stress acting in the z direction, while the stress acting in the horizontal direction as plus 30. So using that, when we calculate the radius, sorry, it's come out to be 30, and hence the principal stress value is also calculated as plus 30 and minus 30. So the problem associated with the same get solved out. Now talk about the applications in civil engineering. It's anything which we read, it must have some application. If it doesn't have application, there is no need for those discussions. So let's see that what are the applications in civil engineering related to this. Okay, so give me a minute, then I will begin. Only 1 minute, please. Okay, so what I am telling that anything which we are discussing become very much important, but its importance, whatever topic we read, first of all we talk about what is the topic, what are the content we are discussing over here. Once the topic understanding get developed, what is the importance, and subsequently the application parts come into the picture. So these are the three steps. First of all, the understanding of the problem. Once during the understanding of the problem, its importance to develop the understanding of the specific subjects is prominent. Subsequently, what are the applications which we studied is very much important to develop the understanding as well as the interest for the concepts or maybe the subjects. It is related to the all the subjects. So let's see what is the applications part of what we have read in the civil engineering. I will also suggest you over here the 4 questions is mentioned based on the Mohr circle. So you try to solve it by your own hand. Again, these 4 problems, very easy problem, and one base slide you can use which is like this equation and these equations to develop the understanding of the problems. Right now, we are talking about the applications in the civil engineering. So its application in civil in talking about its application, it is used in the infrastructure development in the hilly terrains. Additionally, for the cutting slope in creating the benches and road for the pavement. Over also, the shear strength is become very much important as it is mentioned earlier many a times that its applications is prominent all about across the field of the geotechnical engineering. It also help in understanding the critical state of stress and the real life case study of the stabilization slope for constructing the retaining walls. Now you can see over here some of the most important point as it has seen sigma 1 and sigma 3 value. So analyzing the situations where the lateral stresses are more or less than the vertical stresses, so the passive and active earth pressure get developed. So over here it is mentioned that sigma x is greater than sigma z, then the passive state of material, while if the sigma x is less than sigma z, then the active state of material could be there. Now you understood one thing. I think you must need to know that what we say about passive in the term of retaining wall. If you have read, then it's okay. If you not read, let's see. So passive, if the stress is acting toward the direction of wall, it is said to be passive state of stress. While if it is acting away, then it is called to be active state of stresses, right? So in this manner of things gets happen. So the passive state of material and the active state of material get developed. If we read these concepts moving ahead, I will elaborate the things by making the slides, which will give you the better understanding of the topic, right? Now, talking about that, moving with the previous slide only. So you can see when we generalize a state of stress, we say that in a state of stress where the compressive and the tensile stress act on the soil element, the shear stress is also present with the positive value for the clockwise direction and the negative values for the anti-clockwise direction. The orientation of the major and the minor principal stresses is determined using the Mohr circle, and Mohr circle become one of the most important and one of the very easy way to calculate the stresses. Now you can see another problem is mentioned over here, in which the question said that the stress at the point in the soil mass at 35 degree using the analytical method. Over here the stress acting in the vertical direction is compressive in nature, while the stress acting in the horizontal direction is of value 12 kPa maybe is in the in this problem. We have calculated the tau and sigma value respectively using the equation which is mentioned as sigma x minus sigma z upon 2 into sine 2 alpha for the shear stress, and sigma x plus sigma z by 2 plus sigma x minus sigma z by 2 cos 2 alpha for the cos 2 alpha for the sigma stress. So you can then understanding could easily develop. Now talking about the Mohr-Coulomb failure criteria, the functional relation between the normal and shear stress on the failure plane can be uh, given by the as a function of sigma, and it is mentioned very earlier in this class only that S is nothing but C plus sigma and tan phi, where C is the cohesion and phi is the angle of internal friction. Now you see this figure in which The shear strength value is presented on the y-axis while the normal pressure is on the x-axis. Over here, the stress is always linear from 2000 from a specific value onward. Now, over here, you can see that the saturated condition S is equal to C plus sigma dash tan phi, where sigma dash is sigma minus U, where sigma is the total stress and U is the pore water pressure. Now, sigma dash is the effective stress, while the total stress is known as sigma and U as a pore water pressure. Okay. 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 So over here you can see some more important point, that the intercept made on the y-axis while drawing the shear strength versus normal stress graph. If the stress acting on the vertical axis is going to be the the intercept acting on the vertical axis is going to be cohesion, while the angle it made with the horizontal is known as a phi. And in this regard, we have calculated the effective stress. Now, talking about the definitions of key term, the shear strength of a soil is a maximum internal resistance to applied shearing force. The effective friction angle is a measure of shear strength of soil due to friction, and while the cementation is a measure of the shear strength of soil from forces that cement part and the particles. The cohesion is a measure of intermolecular forces. Apparent cohesion is the apparent shear strength at zero normal effective stresses. The critical state is a state reached in the soil when the continuous shearing occurs at the constant shear stress to normal effective stress ratio and constant volume. Talking about the dilation, it is a measure measure of the change in volume of soil when the soil is distorted by shearing. Okay. Okay, now let see some other point about the shear strength and its calculation techniques before summing of the today's sessions. So now I will move very quickly talking about the shear strength. Basically, I just want to discuss the thing with you, which are there in the PowerPoint presentations, which has been shown in the previous class. Which points has been already captured, already discussed, but just for the sake of understanding, I will show some points, specifically equations or the parameters which influences the shear strength characteristics. Okay, so I think so that will be okay for everyone. Give me a minute. Okay, now you can see that like in addition to the various factors which influences the shear strength, the some other points are also very much prominent, like the degree of saturations, the particle size and shape, consistency, or the intergranular particles. So you can observe over here that the degree of saturation, the particle size distributions, um, And the consistency and the intergranular pressure also play a important role, which influences the shear strength characteristics of soil. The shear strength, talking about the shear strength in a plane passing through the element of mass that has not been subjected to the external loading, both the normal and the shear strength act. The stresses normal to the plane are designated by a sigma, and those parallel to the given value of tau. There will be a total line components, specifically talking about the three-dimensional component which we have converted to two-dimensional component. We have already discussed. Over here, the equations which we have mentioned over there as sigma n equal to sigma x plus sigma y by 2 plus sigma x, sorry, sigma x plus sigma z by 2 divided by sigma x minus sigma z by 2 sine 2 alpha, while the other equation as sigma x plus sigma z by 2 cos 2 alpha is very much prominent in the understanding the concept. But that equation only for the sigma n is modified as sigma x cos square theta plus sigma y sin square theta minus 2 tau xy sin theta cos theta. In the earlier concept we have mentioned the two term as x and z, but over here it is modified to x and y, so that not the issue. Additionally, the this sigma n is the normal component over here, and after arranging the expressions, we have reached from this equation, we have reached to the same equation in which the double angle expression for the normal stress at a plane can be expressed as sigma n equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta minus 2 tau xy sin 2 theta. While summarizing in the description parallel to the plane, the toy is derived as below, but while discussing its description, it has given as sigma x minus sigma y by 2 sin 2 theta plus tau x y cos 2 theta. Now, talking about the shear strength, the orientation of the principal plane is determined by setting the d sigma n by d theta equal to 0, that is the minus sigma x minus sigma y sin 2 theta minus 2 tau xy cos 2 theta. This equation is also similar to the previous equation as sigma x minus sigma z by 2 sin 2 alpha. Over here, when we write the equation, it is rewritten as minus sigma x minus sigma y sin 2 theta minus 2 tau xy cos 2 theta. So theta could be calculated as tan 2 theta equal to minus tau xy by sigma x minus sigma y by 2. And when we see this equation moving forward, the sigma n equation and the tau equation is mentioned over here for the calculation of the stresses in the two perpendicular direction and their respective shear plane. Now, talking about the Mohr circle, which we have also elaborated and have discussed the problem associated with the same. So, talking about the Mohr circle of stress, the expression of the normal and the shear stress can be represented graphically by the useful device known as the Mohr circle for stress. It can be shown that the local or locus of the state of stress at any many point is a circle. Squaring the expression of the sigma n and tau n are rearranging the term can get and this could be written as sigma n minus sigma x plus sigma y by 2 plus tau n square plus sigma x minus sigma y by 2 square plus tau xy square. Now, the expression and the equation to calculate the radius is given as far below. Now, to found the steps in the constructions of Mohr column, the normal stress are the plotted as horizontal coordinates, and the tensile stress at the considered positions plotted right to the origin. The compressive stress are considered negative plotted to the left of origin. In soil mechanics, the comprehensive stress are not taken positive. Now, over here, the shear stress are plotted as a vertical coordinates. Positive shear stress are plotted above the origin and the negative shear stress are plotted below the origin. Now see this concept mentioned over here, in which it say that the positive angle of the circle are obtained uh, uh, the positive angle of the circle are obtained when the measured in the counterclockwise sense. Negative of the circle are obtained in the clockwise sense, and angle of the 2 theta on the circle corresponding to the angle theta of the element is shown over here. So it is a very better understanding that the theta which we develop in the normal plane, it get converted into double 2 theta for the actual plane, right? Now moving ahead, some more important point about the Mohr circle is that the figure shows that the Mohr circle for assumed stress at the stressed point, assuming sigma x is greater than sigma y is greater than 0, the normal and the shear stress on the vertical plane P give the corresponding of the 1 point on circle as idealized as D plane are also vertical and the 180 degree from the P is located at 2 theta equal to 360 degree on the circle from P, resulting in the same point on the circle. Similarly, the stress on the horizontal and horizontal plane Q and S plane different angle, different single point E. Right, right, no problem. Okay, so okay, so I think so. Let me take some water. Basically, I'm not feeling good regarding my throat. That's why I not very much well while speaking. Right. Okay, so this point already discussed. Just for better understanding and the revision purpose, I am showing it to you. Okay, so let's see. Over here, okay, these things is discussed, so I don't think they need to be discussed again. Now we move to the problem associated with the same. The tau square plus sigma square equal to a square is already discussed in the previous PDF. And the radius is always the tau max value. When it is calculated from the center, its value is always greater than the radius. Now talking about the application of the shear stress. So the state of plane of stress at a point in a body is shown in the figure. Determine the principal stress and the orientation of the plane on which they act. Okay, so this question get missed out. That why it is not there. So leave it. And once the question is there, we could solve. Okay, this problem is here. This problem say that given a major principal stress of 400 kilopascal compressive and a major and a minor principal stress of 100 kPa, determine the maximum plane shear stress and the orientation plane on which it acts. So I have already solved it, but for just for understanding what it say, let me explain this. It say that if we draw
మన గ్రూప్ లో ఉడకబోసుకుంటా మాకు పెట్టా ఎప్పుడైనా గ్రూప్ వాళ్ళే
someone mic on, Chaitanya, please switch off your mic. I request everyone to keep your mic off. If you have any question, you can ask, but nevertheless, it required please don't switch on your mic in the meanwhile when I am discussing. It will disturb the whole class. If some question is there, then there is no issue. You could ask at any point of time. That is not the problem. Okay. Okay. If you remember, we have read the Mohr circle in which the principal stress is known as sigma 1, sigma 1 and sigma 3, which we have drawn on the Mohr circle surface, and we have mentioned as at sigma 1 and sigma 3. So over here, the major principal stress value as 400, right? And the minor principal stress value is 100. Okay, and it is saying to calculate the shear stress, determine the maximum in plane shear stress. So you remember that I have already said the radius of the Mohr circle is the uh, value of the shear stress which can develop. So over here, when if we need to calculate the radius, what we do? We simply do 400 minus 100 divided by 2, because 400 minus 100 is the diameter of the circle. If we divide it by 2, it get converted into the radius, and this radius is the maximum value of the shear stress that get developed. So 400 minus 100 is 300, 300 upon 2 is 150. Okay, so this is going to be our answer. So I have already solved it for you. So let's see the solution plane as well, in which it is mentioned over here that the given is the principal stress sigma 1 as 400, sigma 3 as 100. The maximum in plane shear stress as sigma 1 minus sigma 3 is equal to 400 minus 100 equal to 300. When we divide it by 2, we get the maximum shear stress as 150. And uh, additionally, you can see the orientation of the maximum shear plane is at the 45-degree with the principal plane. This gives the two plane, that is the plus minus 45-degree. One is the plus 45, other is the minus 45, or the equivalently 45-degree or the 135-degree from the major principal plane of the stress. So the final answer could be mentioned as the maximum in plane shear stress as 150 kPa, while the plane of the maximum shear at plus minus 45-degree of the plane stress in the direction as 45-degree from the major principal plane. Okay, now we move to conclude the session with some more discussion, in which the principal plane, talking about the principal plane, is a plane is acted upon by the normal stress only, is known as the principal plane. There is no tangential or the shear stress present at that plane. The normal stress acting on the principal plane is referred to as the principal stresses. At every point in the soil mass, applied stress systems that exist can be resolved into the three principal stresses that are mutually orthogonal, and the principal plane corresponding to these principal stresses are called as major, intermediate, and the minor principal planes, and are also named from the considerations of the principal stress that act upon them. The principal stress sigma is known as the major principal stress act on the major plane principal plane. Now, over here you can see the figure in which the major principal plane is shown and the minor principal plane is presented. The angle with the major principal plane in the previous problem is 45-degree, and it is also 135-degree when we consider at the direction. But if we consider from the negative axis, it is minus 45 degree at that point of time. Okay. Now the tau equal to sigma 1 minus sigma 3 by 2 sine 2 theta, and sigma n equal to sigma 3 plus sigma 1 minus sigma 3 cos square theta. Is this from figure? So now we are seeing that some other condition related to shear strength, like the limit condition. So it has been stated that the maximum shear resistance is on developed when the angle of obliquity equals to the limiting value phi. For this condition, the line OD become tangential to the stress circle, inclined at angle phi to the axis, horizontal axis. An intersecting point that arises from the figure is that the failure plane is not the plane subjected to the maximum value of shear stress. The criteria of failure is the maximum obliquity, not the maximum shear stress. Some other point associated with the same, talking about the strength envelope. If phi is assumed to be constant, okay, if you see, uh, let me, okay, over here the figure is already mentioned. If we draw a Mohr circle, and when we draw a tangent, and the this, if phi is assumed to be constant, if phi is assumed to be constant for a certain material, then the shear strength of the material can be represented by the pair of line passing through the origin O at angle plus phi and minus phi to the OX axis. These line comprise the Mohr circle, Mohr strength envelope of the material. Talking about the state of stress represented by the circle A, is quite stable as the circle lies completely within the strength envelope, and the circle B is tangential to the strength envelope and represented component of the failure plane. And the circle C cannot exist as it is beyond the shear strength envelope. Okay. Now over here some relations are mentioned, so that is irrelevant at this point of time, because some more discussion could be required. Now the what do we mean by cohesion, we already read with the other PowerPoint presentation, but let me read this for you, that it is the possible to make the vertical cut in the silt and the clay, and for this cut to remain standing unsupported for some time, that it doesn't collapse due to its own weight. This cannot be done with the dry sand, which can removal of the cutting implement will slump until its slope is equal to the angle of known angle known as the angle of repose. In silt and clay, therefore, some other factor must contribute to the shear strength. This factor is called cohesion. As you know, on that the in the cohesive soil, it doesn't collapse very easily. But if the sandy soil is there, if you want to make some excavation, some support need to be provided that doesn't require for the cohesive soil up to a certain depth. Okay, so over here you see I already discussed this also, that cu intercept on the tau axis is the cohesion, and the angle it met with the horizontal axis is angle of internal friction, and how it get developed with the direct shear test and the triaxial test we are going to discuss in the next class. Uh, and talking about the shear strength, it is mentioned as tau equal to c plus sigma and tan phi. In this figures, the c is shown and phi is also maintained. Sigma n is the normal stress, and tau f is the shear stress. So it can be seen that the shear resistance offered by the particular soil is made up of the two components of friction and cohesion. The frictional resistance does not have the constant value, but varies with the value of the normal stress acting on the shear plane, whereas the cohesive resistance has a constant value which is independent of the normal stress. Talking about tau f is the shear strength at failure, c is the cohesion, sigma equal to the normal stress, and phi is the angle of internal angle of shearing resistance or angle of internal friction. Now the shear strength depend upon the effective stress and not on the total stress. The Coulomb equations must therefore be modified in terms of effective stress and becomes tau f equal to c dash plus sigma dash tan phi dash. Over here, the Mohr Coulomb envelope is also shown that how with the cohesion and angle of internal friction could be found. Subsequently, you can see that with this the concept which we are keen to discuss in this class comes to an end. Now I have some problem associated with the uh, vertical stress problem, which topics related to Bosniak equation, Westergaard equation is discussion in the previous class. So these are the some of the problem which has been asked in the various competitive examinations. So let's discuss some problem related to same. Then we sum up the today's session. It will take hardly 5 to 10 minutes. So be with me for this due course of time, and then we will sum up the today's session. Over here, the question asked at the vertical stress at depth Z directly below the point P, the K value is. Okay, so if you remember, I have said that KB Q equal to K into P by Z square. If you remember from the Bosniak equation, it is Q by Z square into the other term 3 by 2 pi into 1 by 1 plus r square by z square whole power 5 by 2. So this term is k. So the z square need to be there in the denominator. So over here the equation A could not be the answer, B should not be answer, D should not be answer. So option number C is the correct answer. Let's see. Okay, so the option C 7.1, option C is correct answer. Description is also mentioned over here. So I don't think I need to elaborate this. Okay, I have given this problem to solve during the break time. I hope you have already solved, but if you couldn't, let me show you the solution for this problem. This question say that the point load of 700 kilonewton is applied on the square surface of the thick layer saturated clay using the Bosniak elastic analysis. Estimate the vertical stress at depth 2 meter and the radial distance 1 meter from the point of application. So you apply the simple basic equation in which you say 700 divided by z square into 3 by 2 pi into 1 by 1 plus r square by z square whole power 5 by 2, where r is the 1 and z is the 2. So you could able to calculate. So let me show you the solution directly, in which they have calculated in the similar manner 3q by 2 pi into z square into 1 by 1 plus r square by z square whole power 5 by 2. When they have calculated, the answer comes out to be 47.8 kilonewton. So the option D is the correct answer for this problem. I think so. This thing is very much clear. If you have solved any of the problem after the previous class, or those problem which we have discussed over there only, then this question is very easy for all of you. Now, the next problem say that a 25 kilonewton load act on a surface of an infinite elastic medium. The vertical pressure intensity in kilonewton per meter square at the point 6 meter below and 4 meter away from the load will be. So again over there the Z value is given as 6 and R value is mentioned as 4. So you apply the same equations and you could calculate the stress, which comes out to be 0.132 kilonewton per meter square. Okay, now you see the next problem asked that a vertical stress at some depth below the corner of 2 into 3 meter rectangular footing due to the certain load intensity of 100 kilonewton per meter square. What will be the vertical stress in kilonewton per meter square below the center of 4 into 6 meter rectangular footing at the same depth? So you apply the same concept as given over here as sigma 1 upon sigma 2 equal to a1 by a2. A1 is mentioned as 2 into 3 and 100 is the stress developed over there is also shown. So you could able to calculate the sigma 2 value as 400 kilonewton per meter square. Yes, the option D is the correct answer for this problem. Now come to the next problem, in which a question say that a footing uh, 2 sorry 2 meter into 1 meter exert a uniform pressure of 150 kilonewton per meter square on a soil, assuming the load dispersion of two vertical, one horizontal. The average vertical stress in kilonewton per meter square at 1 meter. So just you need to calculate 250 multiplied by 2 into 1 divided by 2 plus 2 into 1 plus 2. Basically, if I calculate right, answer is going to be 300 by 300 by 300 100 by 250. So if I could calculate correctly, option number A is the correct answer. Right. So see, option A is the correct answer for this problem. How? The solution is also not mentioned accurately. So let me calculate you. It is going to be 150 kilonewton per meter square multiplied by 2 into 1 divided by B plus 2nz. Basically, the stress we have calculated. Now it is the two vertical, one horizontal dissipation, right? So it become B plus 2.
మేడం సునీత మేడం డబ్బులు మాకే కదా మాకే కదా.
Please keep all your mic off, please. Okay, so 2b plus 2nz होता है. So 2 into n is 2 vertical, 1 horizontal. N is going to be 1 by 2, and z is again 1 meter. So into 1 b plus 2nz multiplied by, then again other term become 1 plus 2 into 1 by 2 into 1 is 1. So it is going to be 150 into 2 as 300 upon 2 plus 2 into 1 by 2 into 300 by 3 into 2 is equal to 50. Right. Okay. So with this problem and understanding developed, and the solution is not there, but I have made it with hand. No problem. Next problem say that the vertical stress at point P1 due to point load Q on the ground surface is shown in the figure is sigma z. According to Bosnick equation, the vertical stress P2 shown in the figure will be, so this value is sigma z at P1, and so what will be value at P2? So then again use basic concepts of Bosnick equation, and the value is obtained as option number D, that is 4 sigma z, right? So you could solve it by yourself. I don't think I need to discuss this in detail. This is very simple problem. Now we came to the last problem of the day, in which it is asked that a uniform distributed line load of 500 kilonewton is acting on the ground surface based on the Bosnick theory. The vertical stress at depth 2 meter to 4 meter. So 16 by 4, it is going to be 4. Option D is the correct answer, as I recall. Sorry, option C. And the solution is also mentioned over here. You could see that. Basically, line load is there. For line load, the different relation is used. Right now, okay. So these problems I will give you with you could solve by yourself. So solution is also mentioned for all the problems. I don't think I need to discuss over here, as the time already past 5:10, approximately 5:10. So I think with this we could sum up the today's session. Right. Okay. So thank you everyone for joining. I will suggest you to solve the problem associated with the today discussions in the next class. We specifically focus on solving the problem related to the shear strength of soil, and I am hopeful that this class will be helpful for all of you. Thank you everyone for joining. With this, I will sum up the today's session. Wish you a very happy weekend, and thank you. See you in the next class.